Hi guys, welcome to another C# lecture, part of C# complete course from beginner to advanced here on IT.tutorials. I am Josef Bodnar. The goal of this C# lecture is to talk about how is organized the memory in .NET apps. Let's dive in. In this lesson you will learn how is organized the memory in .NET apps, what is Stack and Heap, what is the difference between Stack and Heap. In order to store data of a certain app, we need memory. When we declare a variable or we create an instance of a class which is an object, or we can use a more complex data type like a collection, actually we occupy a certain space in computer memory. The memory used by apps in order to store data is called RAM. RAM stands for Random Access Memory. RAM memory stores data of an application as an array or block of bits made of 0 and 1. RAM memory is divided into pieces of 8 bits called bytes. Each byte has an address, as you can see in this picture. This is the address for this byte, 0. Another address for another byte is 1. Further is 2, and so on. When, as I told you, when you declare a variable, an object, or a complex type like collection, all these types need space in RAM memory, and they will be stored in RAM memory. They will occupy a certain space of memory in RAM memory, as you can see in this picture. I declared in A variable which has the type integer, and this variable was assigned by this value 10. This variable, this is just an example, occupy this size 4 bytes, as you can see here, yeah, and the address is 0, 1, 2, 3. So this is an example to make a picture in your brain how the variables, the object, are stored in RAM memory. In .NET, Common Language Writer, or CLR, is the one that manages RAM memory of an application. The memory of .NET application is divided in two parts, namely Stack and Heap. Now here you can see the difference between Stack and Heap memory. Stack stores the variable executed on the top. Actually, Stack keeps track of code execution. The Stack memory is organized based on LIFO strategy, last input, first out, while Heap is a single entity that is shared by stored objects. Stack memory is a small memory space between 1 and 4 megabytes. 1 megabyte is for 32 bits based processor, and up to 4 megabytes is for 64 bits based processor. The stack memory is fixed, cannot be modified, and depends on operating system, while heap memory space is bigger. Heap memory is dynamic, can be modified according with storage needs. That means the heap memory can shrink or expand according with the storage needs. Stack memory does not have memory gaps. Stack memory is organized on contiguous blocks, while heap memory is allocated in random order, and because the memory is allocated in random order, the heap memory can be fragmented. Stack memory is cleared automatically by operating system, while the heap memory is cleared by garbage collector in C# and .NET. But in other programming languages, the heap memory is not cleared automatically by a certain service like it does in C# and .NET. For example, in C++, the heap memory is not cleared automatically by a service. The programmer is the one who manually should declare a statement to clear the heap memory. The stack memory runs faster, while the heap memory runs slower because the memory is allocated in random order, and the memory can have gaps, and also because those reasons the memory can be fragmented, and that's why even if the memory is not cleared properly by programmer in other programming languages, the memory will heap memory run slower and your app will perform slower, unfortunately. Stack memory stores the value types like integer, float, and double. These are the real numbers, or bool, which is the type for boolean. While the heap stores reference types like class, interface, delegate, object, string, and so on. Here you have a picture about stack and heap, and you can make the difference in this way about these two type of memories, stack and heap. Here in a heap memory we store the objects. These are objects: school, students, and teachers. Actually, these are instances of a class. So this object school is an instance of school class. Students is an object, that means is a instance of this class students, and also these teachers is an object and is the instance of this class teachers. These are reference variable. The reference variable are stored in stack. They are referencing the objects. When we create an instance, we have to declare a reference variable which will reference the object itself. Here, this variable reference this object school. Another reference variable reference this object students, and this variable reference this object teachers. For example, this reference variable become null. That means this reference here will disappear, and now this object is unnecessary, is useless here inside this heap memory, because it's not referenced anymore by any reference variable. So that means it's unnecessary. Occupy unnecessary space memory here in heap. In C#, the garbage collector will remove this object automatically, but in another programming languages you have to write a special statement to remove this unnecessary object. And as you can see here in heap memory, we have gaps, as you see, between these objects. But here in stack we don't have gaps, as you can see, because the stack store the variables like boxes which are stacked above another one. Yeah, so as you can see, we don't have gaps. Now this object teachers will be removed by garbage collector, yeah, and the heap memory will shrink. Yeah, if you create another instance, the memory heap will expand, and in this way the heap memory is dynamic memory, can be modified according with the storage needs. Yeah, okay, now let's ignore this heap memory. Yeah, and let's focus on stack memory. If I remove these variables here, these reference variables, and if I declare the three variables like A, B, C, yeah, value type variables, and if the first executed will be, let's say, the A variable, so that means the A variable will be the first stored here in stack. The next executed variable, if will be B, So B will be stored by stack on the top above this A variable. And if the last variable executed by compiler is C variable will be stored on the top of the variables executed before, in our case A and B, and will stack above those variables. So in this way, the stack memory store the variables inside its memory. Now, when these variables are not used anymore, they become unnecessary. Actually, the operating system to remove these variables from stack memory automatically, and we start with the last variable stored inside the stack, which is stored on the top, the C variable, and after will be removed the B variable, and the last removed will be which was the first stored in stack memory, namely the A variable. So in this way, the stack works, and also this heap memory works. This was all about this lecture, how is organized the memory inside the .NET apps. We learned in this lesson how is organized the memory in .NET apps, what is stack and heap memory, what is the difference between stack and heap. Thank you for watching this C# lecture. See you next time. Bye bye.